Here we are on exercise 3, which is on page 45. We're being asked to find the following difference and represent it on the number line. -5.5 take away -8. -5.5 subtract -8. And we can absolutely pop back to our rules. We're taking a negative number, we're subtracting a negative number from it. And the first rule we'll look at is subtracting a number is the same as adding its additive inverse. So we can rewrite this problem as -5.5 plus the opposite of -8. Opposite of -8 is +8. And then we're left with an addition problem. -5.5 plus 8. We take that, look up here, we've got adding rational numbers with opposites, add rational numbers with opposite signs by subtracting the absolute values and using the sign of the integer with a greater absolute value. And looks like we've got an absolute value of 5.5, absolute value of 8. So we can subtract 5.5 from 8, and then whatever this is, we're going to use the absolute value, or the sign of the bigger absolute value. Okay, so 8 minus 5.5. Okay. How can we do that? When we have 8, we've got taken away 5.5. Many different ways you can do that in your head. The way that I like to think about it, that I've said before, is I can break this up into 5 and 3, and I'm taking away 5.5. So I've got 3 now minus 1/2, and I think it's a lot easier to think of 3 less 1/2, which will be 2.5. You could break it down further, though, to say 2 plus 1/2 plus 1/2, because 2 halves is going to make a whole. Take away 1/2. 1/2 minus 1/2, just like 1/2 plus a -1/2, that is going to be 0. So we've got our 2.5. And our sign here was positive. So we start off, we took -5.5, and we want to write that on here because there's no way that you could look at that and say whether that's -5.5, and my line doesn't even look like -5.5. That's why I have to write it on here, -5.5. I'm going to take away -8. And if we think about this on the number line, we know that if we take away any number from itself, we end up with 0. So if I was to do -5.5, and I was to take away -5.5, I think it makes sense that that'll end up 0. We're going to be further taking away another whatever would make up 8. And that's, of course, going to be another -2.5. So we're going from here to here. So our utility of using the number line to actually solve it is going down as we start working with rational numbers. But it's still okay for representing what we did. So we've taken it out, taking away our negatives is putting us towards the positive. We've gotten to 2.5, and we circle our answers. And then again with exercise 4 on page 45, please continue on through exercise 4 and see if you can find the following sums and differences: the answers to the addition problems, the answers to the subtraction problems. Go ahead and pause and come back when you're done. And glad to have you back. We are taking -6. We're adding 5.25. And you may have found that that is -3 and -3/4. And how can we do that? I will tell you that the way that I like to think about it, I've got -6, I've got 5.75. I can break that up into -5, -1. I've got this broken up into 5.75. And I've got my zeros there. I'm left with -1.75. Oh, yeah. I just got all the way to there. And I see that I wrote down my problem wrong. Okay. I figured out the answer, and then when I'm trying to tell you how I solved it, I write it down incorrectly. I'm remembering the 3/4 instead of the actual problem, which was -6 plus 5.25. So -6 plus 5.25. I'm still going to break this down into a -5 and a -1, and I'm going to break that down into a 5.25. I'm still going to get zeros out of those 5s. And now I've got my correct numbers here, -1 and 1/4. And I can further think of -1 as 4/4, or 4 -quarters. Just like a dollar can be broken into 4 quarters, 1 can be broken into 4 quarters, and we can think of -1 being 4 -quarters. So I have 4 -quarters, I've got 1 +1/4, and I can make a 0 out of those, leaving my 3 -quarters. Okay. Finding that using a number line model. If I want to find that using a number line model, then I am starting at -6, or I am putting my first line to -6 from 0, and I am adding 5.25. So if I got that as -1, -2, -3, -4, -5, 3, then my 5.25, and it's pretty easy for me to see that if I'm adding 5, I'm getting up to 1, and then what's happening? Or, sorry, getting up to -1, and then what's happening? So I've gone 5 to get to -1, and then I've still got a quarter, so I'm going a quarter further, plus 5.25. And since I've gone 5 to get to -1, then I've gone 1/4 more to get to -3/4. That's my answer for that one. 7 minus -9/10. So according to my rules, 7 minus negative 9/10, subtracting a number is the same as adding its additive inverse. I will add the opposite of negative 9/10, and that will be positive 9/10. 7 and 9/10 is just like it sounds, 7 and 9/10. And for this one, it's going to be much easier for me if I start at 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's going to be 8 there. I started at 7, and then I add 9 out of my 10/10, and I get to 7 and 9/10 by adding 9/10. I could also write that as subtracting negative 9/10. I've got 2 and 5/10, and I'm adding 1/2. So we need an extra step here, I think, because it's not very easy to think of adding a fraction to a decimal. So you can go either way on this one. You can change the decimal into a fraction or the fraction into a decimal. We've got negative 1/2 there, and we've got 5/10 there. I'm going to go ahead and change that into 2.5, and I'm going to add negative 1/2. And I can see right away there that I've got a half, a negative 1/2, that are together going to make 0. And if I make my number line, it doesn't want to be flat. I'm going to start off at 0, 1, 2, 3. I'm going to get my first one halfway between 2 and 3. I'm taking 2.5. And I'm adding negative 1/2. So I'm going back in the opposite direction. Negative 1/4 plus 4, which is D. Negative 1/4 plus 4. One nice thing about addition is that I can switch these around, because addition is commutative. It means numbers can commute, they can move around. So I can change this to 4 plus negative 1/4. That's easier for me to think about. I don't know about you. 4 plus negative 1/4. I'm going to go ahead and break down my 4 into 3 and 4/4. 3 plus 1/4 plus 1/4 plus 1/4 plus 1/4. There I've got 1, so my 3 and my 1 makes 4, and then I am adding negative 1/4. See that I've got a quarter and a negative quarter. I make a 0, so I'm left with 3 and 1, 2, 3/4. When I put that on the number line, come on, straighten out. There we go. I'm starting out at 0, and the utility of a number line is getting less and less because this is going to be a bit of a pain to try to represent going 1/4 that way and then 4 that way. And trying to figure out where it is. But we can rely on the fact that we already did it over here. And that is the end of exercise 4. Actually, no, we've got E on the next page, page 46. Hopefully you turn the page. If not, pause, do that one, and then you can see E. We've got 1/2 minus a -3. We're going to swing back to our rules. Subtracting a number is the same as adding its additive inverse, so I'm going to add the opposite instead of subtracting. So when it says add the opposite instead of subtracting, this is the number I'm subtracting. I'm taking away -3 from 1/2. So instead of subtracting -3, I'm going to keep that 1/2, and I'm going to add a +3. And I'm going to go ahead and use the commutative property. I'm going to switch those around, because when I say 3 plus 1/2, I might also read that 3.5, which of course is equal to 3.5 written as a mixed number. And when we get to our number line, I'm starting at 1/2, or starting at 0 going to 1/2 with my crooked line, and I am subtracting a -3, which is getting me over here. Subtracting -3. We can also think of that as adding 3. And that gets me to 3.5. And in these examples, the number line, for me at least, was of limited utility except for the purpose of representation. And I might do